Hello, Pre-Calc Honors. This is Mrs. Orloff, and I am back doing the 2.5 Day 2 notes. All right, so I'm going to start with an opener. I know that's a little unusual on a video to do an opener, but I think you should try this first problem on your own. We're going to do this one problem at a time, and then we'll get to the other problems. I'd like you to try this first one and just sketch a graph. When I say sketch a graph, you're just estimating some of the behaviors that might occur. So I want to encourage you to pause the video at this moment and go ahead and do number one. All right, here's my graph, and I'll do a little explanation of it. Things I thought of what my zeros are, and if I had multiplicity, and you could see that written over here. I know that factor of x squared plus 1 creates, we have these complex zeros that happen to be imaginary, x equals plus or minus I, so those will not create x-intercepts. I figured out the leading term was x to the fifth. So an odd degree term with a leading LC, when I use that in my notes, means leading coefficient, that's positive. I find that leading term by multiplying the highest degree terms on each factor. And so I knew my end behavior, and I know the behavior when I have multiplicity of 2. It doesn't look like it, but right at -5, graph touches the x-axis and bounces right off. It's going to slice right through at x equals 0, and that is that graph. Now I really want you to take some time to do the following. Sketch a graph of a quintic, if possible, with the different scenarios. Now these are different scenarios. You're not doing all of them. So you're going to have 4 different scenarios, A, B, C, D. A does not apply to B. All right. A quintic is a 5th degree polynomial. So do what you can do. And then I'll come back and we'll explain this. So once again, please pause the video. Okay. Before I explain this, I really should start being a little more careful when I say a 5th degree polynomial function with real coefficients. I want to make that clear, because if they're not real, if they're imaginary, some things can happen. So for A, it's not possible, and I gave a really mathy type of explanation. You might say, you know, the end behaviors and talk about that, but you know, you guys are leading into a calculus class, so I want to really do a good job explaining this. It's not possible because all polynomial functions with real coefficients are continuous. Therefore, the intermediate value theorem applies. And you guys had that in a prior video, I want to say 2.3, talk about intermediate value theorem, or if a function's continuous, all the values between, let's say, A and B, all the values between that, the outputs will also be hid. And since the range goes from -infinity to infinity for an odd degree polynomial function, then the function must equal 0 at least once. So there must be at least one real 0, one x-intercept. For real zeros with a polynomial function with real coefficients, that would mean I'd have to have one imaginary 0. And if they're real coefficients, we learned in the prior lesson that if I have a complex number that is a 0 with that imaginary part, then its conjugate is also a 0. So they come in pairs. And if that happened, I'd have 6 zeros. But I would have exactly 5 zeros with a 5th degree polynomial. All right. So the last one before I really get into the notes, this is just kind of recapping some things and thinking about this on a deeper level. How many complex and real zeros does this function have? F of x equals x cubed minus 3x squared plus x plus 5. And so I am telling you, your graphing calculator is okay. So use that and then we'll make that decision. Okay, I'm not projecting my graphing calculator, but I did do a rough sketch. And I noticed that it had an x-intercept at -1. It only has one x-intercept. I know the multiplicity is linear because it cuts through in this linear fashion versus having a little curvature there. And so the complex zeros, be careful. If the degree is 3, there is 3. Whatever the degree is, there are 3 complex zeros. Complex zeros covers the reals and the imaginaries, both. It houses both. But how many real? Since there's only one x-intercept, there is only one real 0. So I know I have 1 real 0, 2 imaginaries. That totals to the 3 complex. So I hope everybody's feeling really good about division. Because at this point in time, I want to determine if 1 minus 2i is a 0 of that 4th degree function. And then we're going to find all the other complex zeros of f of x. And I can think of 2 approaches just off the top of my head to this problem. And so I am going to show both. I like to give my students options. And whatever option works for you, great. I'm going to start with synthetic division with a complex number. But what I do know is if 1 minus 2i is a 0, then 1 plus 2i must be a 0. And anytime I'm saying, you know, when we talk about polynomials, again, we got all those real coefficients. So I'm going to start the synthetic division by putting 1 minus 2i on the shelf. This will get a little ugly as we go into this. Check descending order for degrees. So 1. Okay. And I'm going to go through this division, and this is going to be the first round with an imaginary number is a little icky, for lack of a better way of saying that. But we can do it. And so here we go. Let me pick a color. If you notice, I try to have some cheerful colors. I bring down the 1, and I have 1 minus 2i. Okay. I add that together. I get negative 1 minus 2i. So now I've got to multiply this and this. Go ahead, multiply that, pause the video. I'm not going to show that in the video. So after multiplying those two together, I did get negative 5. I'm going to erase that highlighter. And so now I add this together and I get 9. And then I'm back to having some more ugliness going on there. Right? And then I go ahead and again, pause the video and multiply that by the number on the shelf. And so I got negative 45, and then my remainder is 0. So I'm like super duper happy about that because it is. 1 minus 2i is a 0. Not an x-intercept, but a 0, a solution, a root. I am not one who's going to draw or make a new thing, so I'm going to divide it again. So you're seeing that I'm creating my new synthetic division. I'm going to use a different color so we don't get lost. And now I'm going to divide using its conjugate, 1 plus 2i. And I'm going to bring down the 1, and now you're going to see how quickly this gets pretty. That's 0. And yay! But I've divided a 4th degree twice. It's the first time I get a cubic, the second time I get a quadratic. So x squared plus 0x plus 9 equals 0. So I get x squared equals negative 9. So x equals plus or minus 3i. So I have 4 zeros. I'm just going to highlight them instead of listing them. I know in my prior video, one of my students caught that though I said and within what my zeros were, I wrote down the wrong ones because I got lost in my work. So I'm going to highlight them. I'm going to make sure I got them. There they are. Those ones, those 4 that are highlighted. So I did claim that there's another method. I'm a fan of the synthetic, but what I could do is take these zeros that I just circled in blue. I guess I'll highlight them in blue too. Take those zeros and develop the quadratic in which they came from. So I could do that using my shortcut. If I take the opposite of their sum, I get -2. And if I take the product, I get 5. So I get this. Or you could put them back in factored form and multiply them. So I'm going to erase that because I wrote that way too big. And now I'm set to do long division. But the first step is to create the quadratic out of the two imaginaries. And so now I can go ahead and run through this doing long division. I'm not going to work through that because we would get the same answer. I just wanted to show you the setup of using long division versus synthetic, and there's that one extra step of creating the quadratic. So I now have a you try. I really want you to take a moment and see if you can work through this yourself. When I come back to the video, I am going to work through it doing long division since I really didn't show that in the other example. But synthetic or long works just fine. Okay, as promised, I'm going to create that quadratic and do this is long division. I'm going to use that trick that I showed in the prior video, where as long as I think of A, my leading coefficient being 1, then I think about B coming from the opposite of the sum of the zeros, and C coming from the product of the two zeros. And the opposite of the sum is -6, and the product is going to be 13. Do not forget that I squared equals -1. Fun fact. Okay, so I do have this quadratic. And then I'm going to go through my long division. Right here. I'm going to go quick now, so stay with me. Here we go. So first thing that goes into it, x squared. And I'm going to simply multiply, I can't speak, multiply that in. And then I'm going to subtract. All right. And when I subtract, I get -2x squared. And I'm going to bring down that next term. X squared goes into -2x squared, -2 times. This seems like it's going to go pretty quickly for us. And that should be a positive 12x. I forgot to bring down my next term. Sorry about that. And when I subtract, I get 0. So my other zeros for this problem is x would equal plus or minus √2. So again, my zeros I'm going to highlight so I don't miss out. All of these highlighted in yellow, those are the zeros to the original problem. So this note sheet was originally for when we were together, right? So like I could do a breakout room or whatever when I say try this with your partner. But I want you to take a moment, and I'm not saying you have to do the whole thing, but I want you to think about it. I want you to truly take a moment to pause the video and think about it. Okay, so we're going to do a quartic, 4th degree. I know at a minimum it has to be a 4th degree because if x minus equals 1 minus I is a 0, then x equals 1 plus I is a 0. And we have this conjugate over there. So we have these 4 zeros. Here's my hint to you, because I'm going to have you pause the video. Make a quadratic out of those 2 zeros, because they would have to come from a quadratic if there's 2, and make one out of that. Pause the video now. So I don't have an equation written yet, but reds with red and blues with blue, I try to make that color coding. So there's my quadratic. Pay close attention. I know that this is some function, y equals, and I'll tell you where students make the mistake. They stop here and they're like, I'm done. But there's one more thing, one more criteria, piece of criteria we have to handle. That has to be a point on it. What do kids do? They say, oh, it's just plus 20. That's wrong. Plug in 0. That's not my y-intercept. That's a y-intercept. What that means is we've got to find that a value out in front. And we're going to use the fact that we have x is 0 and our y is 20 is essentially what we have. And so we're going to go ahead and we're going to plug the information we have in. And we're going to solve this for a. Go ahead, pause the video, solve for a. I get a equals 2. Now notice in the problem, I never stated what form you had to put this in. So don't make this more complicated than it needs to be. I'm going to put the 2 in for a. And I'm going to leave it in this form. Again, I was never told, hey, this has to be in standard form or this has to be in whatever form. All right, here's a really fun problem because I've been emphasizing real coefficients, real coefficients. So I have a situation where I don't have real coefficients. So I want you to read through this and I want you to do the first step. I want you to go ahead and see if you can work through this piece of information here. Pause the video. So the first thing you're asked to do is saying if g of x is a factor of f of x. So I confirmed that g of x is a factor of f of x. Well, if I'm claiming a 0 of that then is 1 plus I, then I have to think about, well, then wouldn't 1 minus I, and that's why you're seeing h of x. That would be that factor that would have been created. And so will that be a 0? So that's the next question you have to answer. And so if I think about h of x and I say, well, this is this, and if I set that equal to 0, x equals 1 minus I. So will that be a 0? Go ahead, figure it out. So I tried to lead you down a path to make you think, well, maybe I'd synthetically divide again. But this is a third-degree polynomial. And now I'm down to a quadratic. This is x squared plus 1 equals 0. So if I solve that, I get x equals plus or minus I. I can only have 3 zeros. So the answer is h cannot be a factor of f. I hope you all have a great day. Thank you for being awesome.